All right, folks, welcome back. It's Jenna again, and today we're going to tackle bias, darks, and flats. The problem with any telescope is that it's going to have its own quirks that will mess up the scientific data. If you're just taking photos with it, it doesn't really matter too much because they're just photos. They're meant to look pretty. But in this case, we have to compare stars in various parts of the frame to each other. You'll notice, for example, that there's a dark line here in this photo, and that this spot is a little bit lighter than this spot, and that this spot is a lot lighter than this spot. If we tried to compare a star here to a star over here, the brightnesses would be not the same. So we need to balance this frame out. There's three things we have to worry about when we're doing that. The first off is the flats. This frame, I'll show you what it looks like. So not with this one. We'll open a flat frame from this data collection. This is what a flat frame looks like. So what happened here is the telescope was set up to take photos that are overexposed, essentially, so they're happening at twilight. If you had a perfect setup, you would point the telescope at a white screen, but we don't have that set up. So we point it at the sky, which is why you can see some stars, and we just let it get overexposed. What you're seeing here is that the middle section of the telescope ends up far more overexposed than the outer sections. This is called vignetting. So that means that in this photo, this area here will be brighter. You can also see that there are some spots where it's darker. That's little dust particles that are on the telescope. And ideally there are no dust particles, but we're not in California, so we can't clean it off. That means that every once in a while we have to take new flat frames just to make sure there isn't more dust on the lens. Now, you might be thinking one of the issues here is that this has some stars in the background, and won't those show up? What we're going to do is create a flat frame out of many flat frames, which you can see here in our robotic telescope data. If we navigate to the folder that we're looking at, you can see that we have 9 flat files. So we're going to combine all those and get rid of those stars in the background, and then have ourselves just one big frame that essentially shows us where the most overexposed and underexposed parts of this particular telescope are. So that's the flats. Then we have the bias frames. So I'll open up a bias frame. Here's a bias frame. This is taken with, so it's an image taken with a 0-second exposure. So it just tells us where on the chip, where it's recording all the data from our photos, where that chip tends to overexpose or underexpose. So this is where you can see that, this section of this photo is a little light, and then it's dark, and then it's light again. You can see a little bit of that here as well. So we're going to stack these all up so it's even across, again, just like the flats, and we'll apply those. And then finally, we have the darks. The darks are a set of images, we'll pull one up, that are taken at the same exposure as the ones that we're taking for data, these ones. So for example, if this one was set for an exposure of 30 seconds, so would this one be. And it's taken with the lens cap on. So this shows essentially where, what hot pixels there will be at a given exposure. So for example, if you're doing a longer exposure, if you're doing a minute-long exposure in this example, these areas would be even brighter. So we need to adjust that based on the exposure time. So we take a new set of darks every time we take data. You can see that there's little spots that are broken pixels here. We have little hot pixels over here. So again, we're going to stack all these up and build ourselves one single frame that we can apply to all of our images. And I'm going to show you how to do that.